YouTube. I think this is where we left off. Well, I mean, we took a breather and we talked about some design stuff for fun down the stretch. Let's see. So, how was the midterm? Any surprises?
I actually really like the way that we did it. I feel like, I spent quite a long time studying the questions we went over, and I think it was really good.
That's cool. Did I screw the date up on this thing? I screwed the date up on this. It's going, but the date is messed up.
Quite a long time.
Jeremy's wanting to make a tabletop RPG, and he recently played another board game where you had to use an app to kind of assist you in running it.
Mm-hmm.
He's wanting to do something like
hang on
that,
a
it looks
second.
like.
Okay.
He's asking me about how to go about it.
What is going on? Is that? Can you hear that audio? Is it coming from me, or was that a hot mic?
Sounds like a hot mic.
Was that us? Because I just jumped over to YouTube, and then to grab this, saw that I screwed the date up, and I don't know if it'll mess everything up if I change the date on the live stream. We haven't said anything yet. Anyway, then I heard this audio, and I didn't know if it was like coming out of my YouTube or something.
Well, I made it to hell.
Are we back on hot mic time?
Tobias, I think that's your mic.
Muted now. Okay, so back to the exam. That should be, I hope that this now, yeah, it changed it. Okay. So I just wanted to say about the exam. What were we saying? You were saying that you liked the way that we did it. Then I got distracted with the hot mic. Let's go back to that. I can't remember who was talking about Blake.
Yeah, I just liked that, I was able to take some time and study out the topics really well. And I feel like I had a good understanding before, but it really solidified it and helped me review it.
Yeah, I think it worked. I think it worked okay. One of the struggles with testing, any kind of testing, is that testing is always a statistical sample. You know what I mean? There's no such thing in any, I don't care whether you're talking about software testing or academic testing or any kind of testing. You're always taking a statistical sample, right? Does that make sense? And so there's no such thing as a truly exhaustive coverage, right? One of the things that's actually a little bit of a philosophical problem, I have a little bit of a philosophical problem with writing code to a test spec, that when you pass the test, then it's good, because the test spec can't cover every case, and so how good is it? And if you're writing to the spec, if you're writing to the test spec, you know what I mean? You may be not as robust in the actual code that you build, that as you might be. You're a little bit too dependent on the test spec. And in a lot of classes, if you gave the answers ahead of time, or gave the questions ahead of time, and then everybody could just go home and memorize on a multiple choice A, B, B, D, E, A, B, and then just like show up, drop the regurg, and then it would kind of defeat the purpose, because there is a certain value in needing to kind of study the space a little bit, right? But in our case, going back through it, I just kind of felt like, I don't know, I just felt like, these are really the questions that I want you to be thinking about. These really are the punchlines for the class, that I really want you to go away with. And because it's short answer. Stephen, we got hot mic on you?
Well, I was waiting for you to be done. I was going to say
gotcha.
something,
Sorry.
but you go ahead.
I think I heard myself coming echo back through. No.
Oh,
anyway.
then I'll mute. Sorry.
No, it's okay, man. But Anyway, all I'm trying to say is that because it's that little essay thing, you still have to like kind of explore the studio space a little bit to be able to have intelligent things to say that are not going to just be like a rote memorization. So you still have to kind of, and as you explore, you begin to see, I hope, some of the connectedness between and all these spaces, and then you're into the spaces in between. Go ahead, Stephen.
I was just gonna call out some praise because, like, when I first started it, like studying for the test, I kind of hated that. This is like, oh, you want me to write so many words and this and that. But I found as I was studying, like, I actually just tried to practice, like, writing answers without looking at any materials to see how I felt like I could do it. And all of a sudden, I come across a topic that I was like, oh, I know this. I write 2 sentences, like, oh, that's all I know. Okay, and so it was
Right.
really, really handy for me to be able to study that way. So I really enjoyed it.
That's awesome. And I wanted to say that I noticed a couple of times, but there was one night I think in particular that I was getting a lot of alerts, on the general text channel, and I just saw them kind of going past, just sort of coming by on my little alert feed, and I was like, my broskies are all studying together, yes, and not I know it wasn't everybody, but it was still like really warmed my heart that there was interaction and give and take and helping each other and I think that exchange is so valuable. I mean, I was obviously, pitching it in the first place and advocating it, but it and I didn't drop in, right? Because I didn't want to be like Dr. K in the house and everyone's like, I don't know, your dad's here, and everybody bails or whatever. I didn't, what I mean? I didn't want to drop in and be like adult in the room. I wanted to let you guys do your thing, and you can hit me up if you got questions. I didn't, what I mean? I didn't want to suddenly make it about me. Um, and lectures at some level kind of almost have to be, about what it is I'm trying to share. But that was when I just tried to stay the heck out, stay out of the way. But it did really warm my heart. I wanted you to know that it was fantastic. Also, I have not yet. I was going to do it, and then a bunch of crap just slapped me starting at about early, well, 8 or 9. Stuff was slapping me already, and then kept up all day um, until now. So maybe right after this, I'm still trying to get to the grading, and then I haven't had a chance to look at it at all. So I don't yet know if my happy place threshold has been achieved, which will help us all to justify the pizza. Uh, you know, you have the bennies of being the small class, so even if everybody sucks, probably there might be some pizza, But I just want you to know I haven't done any grading yet on, or even I haven't even looked at it at all. So there we have it. It falls in the category of um, anyway. Meme number one here, right, was born out of that angst, right? When you put something off till tomorrow and then tomorrow arrives. It's a little rough. It's a little rough. So anyway, any other lingering questions? But I have high hopes looking at everything. Where's Nico's the other Devon? Cougar Boulevard. Yep. I think it's like okay, you know where Utah Valley Hospital is, and there's like it's kind of across the street. So um, you know where the little physicians plaza is? It's kind of appended. Anyway, it's basically just on the east. What is that road that T-bones into Cougar Boulevard? It must be like 400 west because I think 500 west is the hospital road. It's probably 400 west.
I just think of it as being in the same plaza as Neaters in Provo.
It is next to Neaters. You're right. It is right across the parking lot from Neaters. And I think there's a UPS store right there and a McDonald's not that far away. Anyway, Cougar Boulevard, finite search space. So actually, I think that's actually, based on that address, it's probably 300 West is that street. I think of it as like almost across the street from the Physicians Plaza, which is like a doctor's office complex that's butted up to the hospital kind of on 300. But yeah, but we shall do it. We shall do it after April 22nd, my max immunity day. And anyway, I hope everyone's staying healthy, and I really hope with vaccine and just a lot more herd immunity that we can all kind of crawl out of our basements a little bit more, except for those of you who were in your basements before and will remain there. That's your call. You get to live your life. But for the rest of us who have a little more of that extroverted thing, this has been killing us, you know. And so, anyway, I just hope everyone's staying safe. And with everything, I just have a kind of a hope going into the summer that maybe we can begin to normalize between the vaccine and the herd immunity and things like that. I just really hope. And I hope you're all staying safe physically, but emotionally, it's a big toll. You know, a year of this bullcrap, it has been an emotional toll on kind of everybody as well. So that's just reality. So anyway, just I think about you, I think about me. We're all kind of in this thing together, and just know that I hope everybody's coping and getting ready for a little bit of something. And Braden, on the hard shift on the gears, I have no freaking clue. I'd have to go back and double check. Oh, nice, Rick. That's right. There we go. There's Nico's. That's parking. There's the Caneters over on the right. And Nico's is just in that little strippy jiggy on the left. And that's probably my car, you know, in the parking lot. I mean, the odds are high, you know, on any given shot of that parking lot that my car will be there. I mean that only partially in jest. Okay. Yeah, Braden, seriously, if anybody wants to jump in, and once again, man, when it comes to like the little golf patterns and the you know, whatever, Braden has beard good things. By the way, you can edit that. Nico's is great. You have heard good things from me. But just want to say, relative to Braden's question, which I'm actually not in a position to answer, honestly, because I haven't looked at that in a while, and I don't know off the top of my head because I'm not in the middle of it like you guys. But again, I hope that you'll feel like you can jump on and help each other. You know, anybody got a question, and the TAs can also kind of keep an eye out, you know, Tim and Devin. So anyway, okay, enough of all that. But yeah, I really hope everybody just smoked it. I really hope everybody did a great effort on the exam, and I'm going to try to get that cooked very, very quickly. It's all coming. I'm still coming online physically. The single biggest, I'm jumping on the slides now, but the single biggest productivity inhibitor that I experience right now is my ability to just sit in a chair, still with back, leg, nerve. There's still lingering nerve pain. That's my single biggest thing. And if I could just hang out and park without pain, it's actually still a thing. But we'll get there. We'll get there. And as always, I'm going to be more forgiving when I'm the one who's to slow down. So try to be absolutely fair in the end. So, okay, my friends, what I want to do, I kind of want to just zoom through the rest of the class diagrams. We've only got 5 more weeks of class left. And remember, again, please remember the reason why we're going through these UML diagrams. Anybody, did I ask that question? Was that one of the exam questions? Just curious if anybody would like to offer up why does Chuck drag you through these fricking UML diagrams and then tells you you'll probably never use them? Why then am I doing that to you? Thanks, Rick. By the way, I'm going there tonight, just FYI. I've got a meeting with my 2810 TAs to say this afternoon, evening, like 5:30. If anybody wants to drop in and say hi, I would love to see you, but I'm not buying tonight. Not buying yours tonight. Okay, I will be buying theirs, but
for the UML question, I think that there might be a couple things we could say. Like, for one, UML is a good way to help with making use case diagrams, and those have got some intrinsic value. Also, it helps us to describe our system to a third party.
Okay. Those are like the utility. I'll call that, and those are right on, Blake. I will call those utility that resides within the diagram itself, right? And there's a handful of other things we might say. It forces us to disambiguate, right? Because when you're looking at it, you're like, well, what is actually in this class? You know, well, what is actually the relationship? But there's some things that really what I'm kind of leaning there toward is um, what is the impact of understanding these things on us as designers? Having gone through this at all and having just knowing that there's a thing called UML and a little book by Fowler, or even these slides if you want to download them or YouTube or whatever, what does it do to us as designers? I just want to refresh the motivation for why we're dragging ourselves through these UML diagrams. What do you think? I'm going to just wait. What's it do to us as designers? Come on, Bueller.
It makes us think more about the big picture. It makes us think that way.
Okay. Yeah, totally agree. Braden said life is pain, which I can attest to. Said it's a framework, allows us to think generally so we can work in detail. Okay, and then Braden, generally about what, and in detail about what. And while you're maybe dropping a comment or noodling, what I want to really just say, I'm just gonna go ahead and because I know I'm kind of like, okay, read Chuck's mind. And I don't mean to do that fully, but I do want you to have thoughts when that kind of a question pops up. I would love it if you had some, some thoughts that could kind of generate. Yeah. So Braden just said base layer of understanding. To me, what it says is if I know that there's a thing called classes, okay? By the way, let me just go back. I'm just going to look real quick. I'm jumping over to my folder stuff, okay? Here are the stuff I'd like to hit before we're done, at least touch base on. There are class diagrams, which we're in right now. There are sequence diagrams, object diagrams, state diagrams, activity diagrams, and communication diagrams. Approximately one a week. I don't know. Some will go pretty quick. Okay? Communication diagrams, activity diagrams, state diagrams, object diagrams, sequence diagrams. And if somebody says, oh, you've been a programmer, you've learned how to program, you're learned how to develop software, you're a CS major, you got your degree from UVU, good program, all good, everything's good. And then they're like, design this software. If you've been through state diagrams, it's reinforced the idea that you can think of certain things in the sense of states, and that those states can, is a way of designing. Sequence diagrams. Once you see the sequence diagram, you're like, oh, now that I see it, I think of designing in that way. Once I see activity diagrams, I can think of designing in that way. And maybe before it's kind of Sapir-Whorf again, which is that the UML diagrams and all of the notation are like vocabulary for design ideas. Does that make sense? It's vocabulary for design ideas. If I have that vocab, I can think about the ideas. Sequence diagrams, things happen in sequence. State diagrams, things move through states. And when I suddenly think about transitions or inputs or outputs or, these sorts of things, then as I'm thinking like, you know what, I think the software really does look broadly like a state machine. I can start thinking about, well, what are the triggers? It just brings a clarity in my thinking that allows me to design better. That's the bottom line. That really is the reason why we're burning a little bit of time to go through these things. And then I'll ask you exam questions like, what's so great about a class diagram? What's so great about, it's understanding why that's important on a larger scale. So anyway, just a little bit of a refresh post midterm to kind of hit a few things. Okay. Remember that class diagrams, there's a name, there's properties, and there's operations. That is the gist of the ancient notion of an abstract data type, the ancient notion of modularity, the ancient notion of encapsulation, and of David Parnas's coining the phrase information hiding. Okay, information hiding, meaning that the data is put in a wrapper and all the methods and functions are tied in there with it, wrapper around the whole thing. You don't need to know how Little Caesars makes that crappy pizza. You just have to call up, give them your $1.50 for this much pizza, because that's what it's worth. When you could go to Nico's, pay a little extra. So good. Right? You don't need to know all the details. It's encapsulation, it's modularity, and we reduce side effects throughout the entire program. And we lower coupling as long as we have appropriate cohesion in that module. See how that all ties together? And when you say class diagram, it's like all the details are just ways of thinking about that thing that Parnas talked about 50 years ago. Nah, it's not. When was Parnas? Probably the 70s. So yeah, okay, crap, that was 50 years ago. Okay, suddenly feeling my mortality. Somebody want to look up Dave Parnas, Parnas, and just see Dave Parnas information hiding. Would somebody be willing to drop a Wikipedia link or anything? And I'm gonna go bold, and I'm gonna go 1972 for Parnas. For Parnas's information hiding paper, and I might be confusing that with Dijkstra's famous paper called "Go-Tos Considered Harmful." Okay, what is that? Info hiding. Oh, boom factor. Yeah, thank you. Here we go. Boom. Sometimes I just deserve pizza. You know what I mean? Sometimes I feel like I've earned it somehow through some moment of weird lucidity and clarity. 72. Okay, and while we're at it, we ought to double check. Okay, thank you. Thank you for that. We ought to double check Dijkstra's famous paper. Dijkstra. Sorry, it's making me crazy. Now I have to know. Oh, 68. Okay, Dijkstra was 68. I was alive for both of those, turns out. All right. Okay. Yeah, I should have not gotten greedy and gone for Dijkstra. I should have just left it, just leave the emotion in the air that I'm somehow infallible. To all know is not even remotely true. Okay. Let's see. Let's go. Back to class diagrams. I'm just going to rock and roll. We're just going to pound this thing, okay? When we talk about properties right here, right? Loosely, we kind of just think data, right? What's the data? What's the data that's being encapsulated? Also, this is where cohesion is really, really important, because the data that you find, it doesn't have to be just one item of data. It can be a number of things in there, okay? But they ought to be related so that when you say the name of the class, which then becomes the name of the object when you instantiate it, or the type of the object when you instantiate it in your program, Um, there can be, a bunch of data. There really can be a bunch of data, a structure that has all the internal data, some other stuff that's external, a few other, whatever. Think of just like a student node, information for a student. You're building a database for the university, right? What's the information for the student? You could have a record of some form that just has a bunch of fields that are all about the student. But you could also have another record that was like, I don't even know, other information about the student that just was valuable to have. Could be, um, sorry, adjusting my little heater. Could be, transcript information, right? You could have, for example, a single record that would have all these different fields about the student that were like internal, like, whatever, name, UVID, contact info, blah, blah, blah. And some other things. It was like a whole record about that student's financial aid or that student's, uh, transcript or, links to financial things. There's a hold on the thing because you didn't pay a parking ticket or whatever. You see what I mean? You can have a bunch of things, but they should belong together. That's the key. That's cohesion. And yes, it is subjective. Always, always, always pretty subjective. There's no clean answer about what is proper cohesion. There's not a clean answer. So you've got the declarations of the data, right? And but you can just think of them as fields. You know, that's which the data that you declare becomes the data that gets managed by the object when you instantiate that thing and you do a new whatever the language is you're using to take a class and instantiate it to make a new one of these. As soon as that happens, that data now gets allocated somewhere, right? And there are two things we're going to look at primarily, which UML calls attributes and associations, okay? Essentially, it's this stuff right here. All the examples from here on out are from Fowler, okay? And we're going to break this down, but these are the attributes. Those are the attributes. So this is actually the syntax, which you don't need to remember this, memorize it or whatever. But there is a visibility, that's the plus sign, which we'll break these down. There's a name, data received, is prepaid, line items. There's a type, like date. There's a multiplicity, which is what this number is, sometimes called cardinality in other systems. And then there's a property string, if there is one, but there doesn't have to be. So, for example, here's a read-only because it's the minus sign is read-only. You can be public or you can be private. Sorry, that's private. It says sorry. I got jacked by the read-only. The plus minus indicates whether it's public or private, and in this case, it's private and it's read-only. So what that means is that the external folks using this thing don't see it. Internal purposes only. Information hiding, right? We're hiding the information. There's the name. Oh, and by the way, Martin, yeah, every so often, so I've met Martin. He's really a great guy, personally a great guy, has done some great work in teaching, training, writing great books. But every so often, we have these blind spots, like having this name be like what it is, and then calling it name is like weirdly confusing because then you're like, do you have to say name? No, you can say the actual name, like Biff. I don't know. Anyway, that's the only mandatory field. That's the type, which says that's what kind of object can be put into this attribute. Just think of it as the type. How many? Talk more later about multiplicity. Oh yeah, the default value. Default just says what's the default value. If we don't say anything else, if we don't set an attribute when it's being created, like with a constructor, we can say every time this attribute comes alive and we instantiate, start with that as its value. Could be null, could be a value, could be a number, you know, whatever it is. And then property string, which just allows you to just say some stuff. Remember, this is all just diagrams. These are just syntax for notes to the user. The user being the developer, right? All right. There we go. Back to where we started, okay? So let me see. What we've been doing here is saying, here's a line. Here we're saying for this order object, it's got these 3 data attributes. And so we're going to go, there's the visibility, there's the name, there's the type, multiplicity, no default, property string. Okay. So having done that, we can now do things, well, sorry. Association. We talked about attributes, like what's inside. Notice that we just had this thing called order with all this detail inside of it, right? Well, out here, we don't have all that. We bump back up a little bit from an abstraction perspective. And now we're just talking about relationships between the classes. And this is also what we sometimes call, what used to be called static declarative. I'm just going to put that in the chat. Static declarative. And what that means is simply that these are, when we're at the point of declaring the code, we're doing inheritance, we're doing generalization and specialization and, you know, other kinds of stuff. And we're trying to, sorry, man, I'm so confused. We're trying to understand how they get along, how they do what they do. What are the definitions of how they do what they do? This is not while the thing is live and running. Okay, that's object diagram, and we're going to get to it. Okay. So it's all those kinds of things, though, that are associations. And again, we don't need to belabor it. You know, here's where like date received comes in, which is something that order is going to send to date. This is or access is prepaid, is a Boolean value. We've got some source, and then we've got targets. So again, the gory details don't care about, other than to say that we can break these ideas out and show these associations to give you sort of another view of the thing. And what you're gonna notice is that this view right here, which is probably what you're used to seeing if you've seen anything, and this view here, if you look at them, you're going to see that they're very much the same. You know, like there's date, there's date received, there's Boolean, is prepaid, which is a Boolean. There's line items, which is an order line. So the types are in the boxes, okay? So now it's talk time. What do you like? What do you like? What do you not like? Why not like? What say you? Talk to me, friends.
I guess I'm not sure I really understand. What is the... I see there's a 0 to 1 relationship between a date and an order. So does that... I don't understand how an order could have... Oh, wouldn't every order have a date, though?
You would think so, that there could be many orders on that date, right? Yeah, I'm not sure. I'm really not completely sure. Because the notion of an order has to have an order line, and we have to know whether it's prepaid or not. So I guess the presumption would be, Blake, that there could be an order without a date? Or is that the date that the order is received by? How does that work? How does that work? I don't know. I'm
Yeah,
not
I'm not sure.
100% sure. What's that?
Just agreeing. I was just saying I'm not sure.
Yeah, I'm really not either. I suspect that there was at least 2 times in the last 2 years in which I had an epiphany in which I understood why that was the thing, and then it went away. It got pushed out by who knows what. Yeah, what's going on? Well, the date, because I'm also looking at the order on the flow, because what happens is,
I think I get it now.
what do you think? What's your take?
So every order, I guess that date is a date received. So maybe the order is sent and it's not received yet, so that you could have 0 or you could have 1 date received.
You
I
can't
guess in
have
other
2
words,
dates received. That would make no sense.
so in other words, you could say the date received is null, or you have a date received.
Yeah,
But you
the
can
other
only have
question
1.
is, I think the other burning question I've got is that the date that the order was made by a customer, or is that the date that the customer received the order, like via shipping or something? And that I'm not sure about. You know what I mean?
My only assumption can be that it is the date that the customer receives the order. That's the only way that would make sense.
Right. But that feels like slightly funky cohesion to me, whereas the date that the order was made by the customer, you know what I mean? From kind of a cohesion perspective, seems to make more sense. You know, and I don't know, of course. I don't know without looking more into the system. I don't know. I really don't know. It's also one of those things where sometimes it demonstrates that there can be a little bit of ambiguity. So, for example, the order has this is prepaid data, which is of type Boolean, and has to have one and only one, right? Of those, a single order line can only pertain to one order, right? Order lines either don't exist or they're attached to an order, one order. You can't have one order line that's like, I'm on different orders, you know, in our system. But you could conceptualize a system that could have some kind of weird, funky split. It's possible. Let me see. Okay.
I think I understand that top bit now, but what about the bottom bit? Line items ordered. Line items ordered.
Yeah, man. Well, yeah. Let's see. Well, the ordered is like a note to us, right? A little attribute. So that these are, so every order has multiple order lines. And it looks to me like maybe the order is pushing the line item ordered and putting the value into the order line. Then it could create another order line, fill out that, push that out there, another one, another one, another one potentially. So you become almost like a linked list or in implementation, some structure of multiple order lines associated with a single order. And I believe this is trying to say that the order is pushing the value of the line items into those class. That's where that's where the line items, you know, get their values from the order. Don't know for sure, because this is just such a sketchy little example. And then what is the detail? I don't 100% know. It's also an illustration about the fact that you got to be, trying to make these things as clear as possible. And
I'm
usually there's some supplemental text or something. Yeah?
I'm also wondering how it's ordered. Is that really shown here? Is it by the date or by the fact that it's prepaid or not? Like,
Yeah, I don't know. But it is clear that this data structure really is what we're kind of seeing here. The data that resides within this class includes an order which has these three things as part of it: a date, one or more, 0 or 1 dates for reasons we're not 100% sure, and is prepaid flag, and 0 or more order lines, aka line items. Let's move on. We're not going to crack it all the way, but one of the things that I think is really important to show here, though, is that the little traditional box is one classic way. This is a little bit less of a classic way, frankly. You see way more of this upper left thing than you do with the other one. But what you notice is that when you draw it a different way, you see different things. It invites you. It's Sapir-Whorf again. It invites you to ask certain questions that you didn't ask over there, even though the information is essentially the same. And I find that really fascinating. Okay, let me keep going. Multiplicity, we talked about kind of briefly. Range of numbers, here we go. Range of possible numbers of objects that the property can refer to or that the system can create or otherwise support. So back to this one here. This is only one value. This is a range of values. That one's 0 or more. So again, it tells you a little bit about how to implement, though, doesn't it? If there's look, there is an is prepaid. It's Boolean. Where you're like, well, I better set that bad boy upon when it's created, when order is created, my constructor probably ought to set that is prepaid to be like false, or you know what I mean? You start to think about aspects of implementation or further refinement of design or things like that. Yeah, there we go. That cool animation. Go Chuck. Go Chuck with your great animation. Yeah. Okay. These are also unidirectional associations. We can think of them that way. You can also do bidirectional associations. So person can have a car, right? And a car can have multiple persons, although it depends on how you draw this picture. This says a person can have multiple cars. I think it's very clear that a car can not only be abandoned or have an owner, but you can put multiple names on a title. So the reality is, I don't buy the multiplicity constraints on this thing. In my mind, whatever the legal limit is in the state you live in for how many names can go on a title, that's the number. So anyway, because of this, you do have this cyclic relationship, right? If you got a person, you can find their cars. If you find a car, you can find its owner, right? Now, let me just talk for a second about noun phrases. When we're doing design, one of the best things you can do, if someone hands you a spec and says, a requirement, here's the system I want you to build, read it and get two different colored, highlighters. These are Sharpies, but you got the idea. Get two different colored highlighters, and as you roll through, let one of them be nouns, let the other one be verbs, right? And every time you bump into a noun, just highlight it, because every noun kind of wants to be an object, and an object has to be defined. And when we define an object, we call that a class, okay? So the nouns are your hints it's not like, mark all the nouns and that's all your classes. There are going to be classes that didn't show up there that you realize you need. There are going to be, um, there are going to be nouns that don't suggest anything. It's that whole mismatch, but it does guide you quite a bit. Then with verbs, when you see a verb, you got to at some point kind of look back and go, well, who's doing it? Who's doing that verb? Well, that's a noun. Now you start to think about methods, right? So, and when you talk about nouns being classes or objects, they might also be elements within, like a person or a car or a order line, or what was the one, etc. All right, and then the other thing you can also do is represent it literally as a verb phrase, like a person owns a car. You can do that. You're just trying to embody this idea in a way that makes some sense to a developer. Okay, once again, you can kind of do this both ways. Person owns a car, and you could also read that a car is owned by a person. What do you think? Which one do you like better? They're kind of equivalent. What do you think?
I suppose I would say I like the bottom better, just because the top one seems more like if this can go both ways, the owns with the little play button makes it seem like it only goes towards the car to me.
It has, yeah, it kind of feels right. Well, because there's only one arrowhead and it's only pointing in one direction. Yeah, that's true. I'm actually looking back at Braden dropping some what do we call those? Blank regular expressions on us. Rick likes arrows. Yeah, I'm partial to the arrows. I think I'm partial to the arrows. Sam likes the verb. Feels more like how people think. Yeah, and the only problem I have with that, Sam, I don't disagree with what you're saying. I think that is its strength. Because the owner, this is actually a noun phrase in the bottom, and that's a verb phrase at the top. But the only challenge I've got is if I can say owner, car is owned by a person and a person owns the car, maybe if you had bidirectional arrows like owns and is owned by, you know what I mean? With an arrow, so that you would really clearly articulate the relationship. Because it is true that if I start with a car, I can look up a license plate or a VIN and I can see who it belongs to. And if I look up a person, a little harder, frankly, I can find out what their cars are, depending upon states and countries and what have you. Yeah. Here's the other thing, there's this principle of design. You add a label if doing so adds clarity. Otherwise, you're just, clogging it up. So labels like has or has a or is related to, is associated with, worthless. They're worse. They're worse than nothing because they clutter and make you burn processing to derive no value. Because the arrow itself already said is related to, you know. So that's kind of a design principle there. Okay, let's talk about operations, which would, again, we start with it's called an operation, but let's talk about it, as methods. There really are. This is about the methods that are going to be popping. Okay, so here's some examples again from Fowler. Here's the class diagram, just kind of the objects. There's an order, there's a customer, there's a corporate customer. And I don't know if the corporate customer is, I don't remember if it's like inheriting from customer and specializing it. I don't know. But this is the stuff we already had before. Some of it. There's date received, date. I think it's got to be the date the order is received. I think it has to. But I bet you $3 I'm wrong. There's is prepaid. And we had there's a number. I don't know what the number is. Number of what? The order number. I'd make that a little more clear. And price, item price, whatever. Money, which is a data type that we've defined somehow. So I can then dispatch an order or close an order. That seems pretty sketchy as a list of potential methods to work on order. How about cancel an order or update an order or change shipping information or any number of things that you might really do? But it's a dumb example, that's all. Customer has a name and an address. Oh, and there's a method for get credit rating. And yeah, corporate customer, contact, credit rating, credit limit, bill for the month, whatever. Again, is this good design? Not saying it is. We're trying to just illustrate how the UML thing works, okay? So here we go. Here's a balance on. Was that even over here? Yeah, let's drop another one that wasn't even in our prior list. Once again, visibility. That's a public method, which means I can get to it. I can call it. Once I've got this object called, where is, let me see. I don't know which method it's in or which class it's in. But let's just say it was, I don't know, it doesn't look like any of these. Let's just say it was an account, right? And I've got this account called, account 7, and I can do account 7 dot balance on, and I can basically say I'm going to invoke the balance on method from, that particular object that we've instantiated. Okay, yeah, that's that. Again, name of the method. It's the only mandatory field because I could just say there's a method. I leave it all blank. And that means I'm not doing a lot of design right here. I'll do some design later. I'll deferring some decisions. Parameter list, right? What's come when I invoke the method? What's coming with it? If there's a return type, what is it? And then any properties that help. Like for example, just by putting the word query, we're just we make it really clear, or at least more clear, that this is essentially our opportunity to query the balance, to find out, to read what the balance was on a given date. It's not allowing us, probably by saying query, it's not allowing us to say, I want to change what the balance was on a certain date. If it said modifier, then that would be the implication. Let me see. And again, the bottom line is you put whatever you need to communicate. Like for example, here you go bill for the month and there's an integer. This one, and that's all you see. You don't see if there's any return parameters. Here you have string as a return parameter. Here you got nothing, plus, minus, and if you're not going to say certain things, then, you're leaving them for later, kicking the can down the road from a design perspective. Okay. Let me see. Now we get into more of the whole inheritance, specialization, generalization. And didn't we talk a little bit already about the whole inheritance, the sort of death through inheritance thing, which actually leads us to the Liskov substitution principle, which you read already. We'll touch base so briefly. And we're actually really close to the end of these slides. But you understand, you've been taught object-oriented programming. You know that there's this thing about generalization, specialization, inheritance, right? Well, this is your UML syntax, right? Where I can, like if you look at it, like there's association, multiplicity, stuff we already know, the role name, and then like here, like a little constraint that it's like a little note, that little fold over here, like 3x5 card, dog ear, the corner. If the credit rating is poor, then order dot is prepaid must be true. Basically saying, if you pull their credit rating while they make an order, and it's bad, we can't extend them any credit. So that little note just helps us to understand part of the specification for how we're going to build this system. Okay. And again and again and again, I'll say it, the particulars here, class diagrams to me always have a certain amount of clutter that makes them a little difficult to read, frankly. But again, this is not about here, this is the vision splendid of all design, but rather just an example to get you thinking about what the chunks are. Again, these are the attributes. We know what those are. Those are the operations. But right here, and then that's a class diagram. Most of these labels are stuff we've already been through. Then comes generalization. Oh, you remember when I asked the question earlier whether corporate customer was inherited from customer? Looks like it does, right? There's personal customers and corporate customers which specialize the generic customer. So the generic customer has a name and an address, and you can get the credit rating. By the way, obviously there's got to be some other methods like read the name, or read what is the address. Like if I hand you a pointer and say, what's the name of this customer, you should be able to tell me. And I should be able to say, hey, I need to update the customer's name. Got to change the customer's name. Got to change the customer's address, right? There's obviously methods missing here that would absolutely need to be there. But to throw them all in clogs everything up, makes it just so unreadable. Generalization, for personal, we add a credit card number in our world because apparently corporations don't have credit cards. I don't know. But in this world, the corporate customer, everything happens on credit. You know what I mean? You extend them some credit and you have them owe you money payable in 30 days, or you're invoicing, that kind of thing. It's essentially, invoicing is a de facto extension of credit. That's what I think is going on. And corporations have employees. And order lines have products. Every order line has to have a product or it doesn't make any sense. Okay. Let's see. Remember that you've talked about generalization and specialization somewhere to this point, right? Is that true? Before 3450? I apologize that I don't yet know the curriculum really, really well here. Where do you touch object-oriented stuff like that? Hot mic is our only response.
Well, I was debating, and then you asked the question further, where do we learn it? I don't know where we learn it, but I've heard this before.
In a class, in a UVU classroom context?
Yeah, in a class, okay. UVU classroom context.
Okay. Because I'm never quite sure, like, okay, do I need to, have you heard this before? Has anyone not heard this in a class before now? I'm dropping a survey. I'm dropping a survey into the chat, okay?
I think we went over this in software development, but I could be wrong.
Okay, I'm dropping this. I'm dropping this into the chat. Just respond with a yes or no on the reaction. And I'm going to give you the little hand, but you drop a Y or an N, okay? Thank you. Somebody want to drop an N in there just to make it easier? Then on Discord, you just click on the icon. Oh yeah, there goes the N. In the context of a classroom, like you had a class that was required for this class, and in that class, you learned about generalization and specialization. And then anybody who doesn't respond, I don't know, what's punishment? No pizza? What do we do? What do we do to the non-responders?
1 bonus point for everyone that does respond.
There you go. Now I see, I like the way you think. Come on. 8 respondos, and there's like 5 of you have not responded because you're whatever, sitting in a hot tub.
Now we're getting some more.
9. We're still missing 4. 4 people being uninvited from pizza. 3, 2 people losing their pizza now. I'm joking about that, of course, but I'm just trying to jack up the interest in this fairly meaningless little exercise. Okay, all right. Yeah, I'm wondering if there's a path to get here where you haven't heard about generalization and specialization. But I'll tell you this much, by the time you've been through that whole Liskov substitution principle part of the book, of the head first, whatever it's called, the former skater chick book, so this is one of those things that I got to figure out if this should be, part of the curriculum thing that you get before you get here, and if you didn't, that you either got here the wrong way or you like totally just spaced it. It's possible. The whole idea is that with object-oriented programming, I can define certain things like a customer with certain attributes, then they need to be common to all customers, right? This is a direct lead into Liskov, but they need to be common to all customers. So if then I can define, well, a personal customer has a credit card number, but a corporate customer has contact name, which is not the same as the customer name. That's like contact at the corporation, credit rating, credit limit, stuff like that. And anyway, that you can specialize. You can basically take this idea of a generic thing and refine it. That was one of the big deliverables of object-oriented programming and design, right? Like I can have a dog, but I could have wild dogs like dingoes in Australia. I could have domesticated dogs, and among domesticated dogs, I could, push them into, I could add, so I can have this idea of what a dog has, what it is that makes a dog, but then I can say, well, the domesticated dogs versus wild dogs, or I don't even know, right? Allergic dogs versus hypoallergenic dogs, like the famous snickerdoodle or whatever that dog's called, poodles and such. Poodles and other doodles. Anyway, that's the bottom line. But generalization and specialization are basically 2 sides of the same coin. Now, here we go. Let's go Liskov real quick. This is not, I don't want to beat this to death. It kind of, I think, comes across a little, I don't know, it can be a little more hairy because it feels, I don't know, it feels more scientific. But the idea would be that I should be able to use anywhere where I would use just plain old customer, I can use corporate customer, or I can use personal customer. I can ask a personal customer for its address. I can ask a corporate customer for its address, right? That's the principle. So here comes Liskov. Okay, now this is different definitions. This is the formal definition, which I would be just criminal if I made you remember this crap. Let theta, that's theta, right, be a property provable about objects S of type T, then whatever theta of y should be true for object. Little better. If S is a subtype, then objects of type T may be replaced with objects of type S. More intuitive. Objects of a superclass must be replaceable with objects of its subclasses without breaking the app. Meaning that the subclasses, the inherited, those that inherit can't like break. So for example, I can't have a situation where there's a name up here, right? And the name, let's just say, is I don't right. It could be a string, whatever. And then down over here in corporate customer, it overwrites name. It redefines name, right? Which you can do in inheritance. Take something up there and use it, but it's different. And then except here, your name is like some other weird abstraction or an entire new data structure or a name object where that one's just a string or something. So now all of a sudden, when I go to use this, I don't get the same stuff in and out, okay? So here's the practical implications, and then I've got a meme to help you remember the principle. And I don't care if you ever say the word Liskov or substitution principle ever again, but this is just one of those little design things to make you think twice. Everybody's like, generalization, specialization, inheritance, object-oriented, yay, for the win. But understanding that even these cool ideas can just be beat up real bad, right? And I think there was a reading that I dropped on you on whatever chapter the Liskov shows up in. Didn't I drop a little reading on you about inheritance? And that one author was like, don't ever do it. Just don't do it. Don't overwrite anything. Look, build stuff out of other stuff. Use sort of, kind of aggregation to build things, but inheritance. And I've always felt a little dicey about inheritance. Let me be really honest. I chalked it up to being older when object-oriented programming became popular. I was in my 30s when C++ showed up as something we had to know. Yeah, that's right. It does relate to the strategy pattern. So, and so I don't know if we need to beat on it anymore, but accepting the same input parameters, you can be less restrictive, but you can't be more restrictive. Otherwise, it's going to be busted later on. And then this is my little meme just to help you. Okay. If it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. Okay. That is kind of the idea. You know what I mean? I can talk about mallard ducks and one kind of duck and, baby ducks and mommy and daddy ducks and all the other ducks. But once we need batteries, maybe we just kind of broke our abstraction and inheritance suddenly didn't make any sense. All right, that's it. A few other things. What do we got here? 10 minutes, less, 6 minutes? Let me see how many slides I got. Because it'd be great to get through this and just be done. And if not, we'll be very super quick. 7 slides. Let's do it. Slide a minute? Yeah. Besides, honestly, there's some other, like state diagrams, I think are very interesting. Sequence diagrams, interaction diagrams, very interesting. And I want to make sure we don't short those. Okay. Notes. I think my slide says it all. Sometimes you just need to say stuff. That's all. Okay. Sometimes you want to just tack on a note, like it includes pickups and SUVs, but not motorcycles. Okay, fine. That's just tacking on words. That's all. And thank you. That always needed to be there. Dependencies. If something changes, other stuff has to change. Okay, that's the idea. So it's ways of saying that there's a dependency here between benefits window and employees. Now, the existence of a dependency is at some level a manifestation of I almost said bad boundaries, but let's just say bad coupling, okay? The coupling is too high. If there are those dependencies, I think there are circumstances in which either it's legacy and you inherited it, or there's some reason why you were stuck with it. That can happen. Okay? But again, it ought to make you think when you're designing, are there any dependencies coming in here? Or is this neatly, have I done a neat job of modularity, or are there dependencies still lingering? Did I inherit some dependencies from this other system that I can't get away from? The direction matters. What that really means though, like for example, if there's a dependency where the employee depends on the benefit window, I can change the employee. Well, then the employee data gateway depends on the employee, etc. I can change the employee data gateway, and unless it ripples from there on down, I didn't really do anything bad. But if I change the employee and there's some dependency on the employee data gateway, that's the thing. Do you have dependencies with composition? Yeah. That's one of those interesting things, because there's still a sort of like I might say, tell me your name, but I still need to get your name in a way that we've both agreed upon. And maybe it's a string and maybe it's a name object. And that is, kind of does have, that is a dependency, If we change what that is, we kind of break stuff. What else? Can't include all of them. So you include them when there's some clarifying that you really, really need to do. That's the bottom line. Okay. Bottom line, bottom line, just try to keep the dependencies to a minimum. And if you're stuck with a dependency, give yourself just start thinking about, whether you can fix that, whether you can change that, or whether you're just kind of stuck. All right. And let me see what I got. 3 more. You can just tack on constraints. I mean, that's all a class diagram really is, right? Just a bunch of constraints, just organized in a way that makes a little more sense visually. But if that's not enough, I can add, I guess I don't have a picture. I can add, just put other constraints inside braces. Squiggly brackets, caution, don't ever do the one thing. I'm free to do all that. You use all these features to help you understand design. To me, that's first and foremost the value. You become alerted to issues that show up, right? You see the thing, you're like, oh wow, what if there are constraints? When you think about it for a second. Remember again, this is so important. All the features were created for a reason. So if you're new to software, and by the way, by the time you get your undergrads, you're still new to software. You're credentialed and you've done some cool stuff, but you're still new, you don't know all the reasons. So go to school on these things and look at the notations and go, what is that notation trying to teach me? Because remember patterns. It really comes back to patterns. They're idiomatic patterns. These notations within UML, these notations are idiomatic patterns. And what is a pattern? A solution to a problem in a context. Well, idiomatic patterns exist because they are solutions to a problem in a context. What's the problem? How do I represent this idea so that another developer can read what I've done and understand, so she can do the cool thing that she's got to do, right? How do I do that? And then for every little feature, there's like, well, we could just put it in squiggles. We could make arrows. We could make boxes. Every one of those little notational things is an idiomatic pattern. And every one of them was created as a solution to a problem in a context. Okay, next up, Sapir-Whorf. There are things that you really can't think unless you have the vocabulary. So the vocabulary gives you clarity. Oh. And then this last one, so important. The need to communicate drives the usage of the notation, not the other way around. Okay? If you're just doing notation because your organization requires it, I just think it's problematic. You need to do what you need to do to be maximally effective in communicating. Anything more and you've cluttered it. Anything less, and you left some things unsaid that needed to be said. And then finally, last slide. Oh yeah. This is not just about object-oriented software. Class diagrams, those ideas, it's true for a lot of things. Systems, businesses, you know. And one of the advantages of object-oriented programming and analysis is that object-oriented systems look a little bit more like the real world than imperative programming does, okay? And then, you know, do not draw models for everything. Unlike an architect who has to have layout for framing, electrical, plumbing, you know, the architect has to have a predefined set of diagrams. You don't have any of those that are really, truly, truly required. Don't draw it if you don't need it. You don't need a diagram of everything. Otherwise, you're just burning your time for nothing. No one's ever going to read it. And then you just got something to maintain when everything changes. So, all right, that, my friends, is in fact, let me prove it. Oh yeah, proven. Okay, so that's it for class diagrams. I really do hope, sincerely, that that's been interesting. You know, that's still been valuable for you. Even though I know there's a lot of tedium to it, I just want it to pass through. You know, and I'm not making a big production out of drawing a bunch of diagrams and stuff. I don't know. Maybe in the future when I've got my act together. I don't know. Anyway, we're out of time, but that was module 5 or lecture 5 or diagram is number 5, whatever it is. But we're going to come back. Okay, so next time, what we're doing next time is sequence diagrams. And I think from here on out, you're going to find the diagrams a little more interesting and a little more enlightening in terms of what they teach you from a design perspective. And we've got a few more little projects coming up as well. But now that I'm able to sit in the chair. All right, my friends, I'm done. I'm rapping. Not rapping, but I'm rapping. I can't rap. I can drop the beat, but I can't rap. Okay.
See you next time.
See you next time.
Very.
Thank you.
Do not be jealous of my Chick-fil-A cookie. Do not be jealous of this cookie. But it's waiting for me. Okay, everybody.